Draw a scatter plot that graphically shows the relationship between the losses and your insurance payment. So here, what you want is a graph that shows the relationship between the losses. As we can see here, we have the losses and then the insurance payment. Now, what is a scatter plot in the first place? So let's talk about what a scatter plot is. So a scatter plot or a scatter diagram is a plot of pairs x and y quantitative data with a horizontal x-axis and a vertical y-axis. The horizontal axis is used for the first variable, and the vertical axis is used for the second variable. It is used to determine whether there is a relationship between the two variables. Each member of the dataset gets plotted as a point. Okay, so here, like, you use it's a graph that shows if there is a relationship between two variables. So for example, the local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. So what they're doing is that they look at the temperature of that day at noon, and they count the number of, like, the amount of money that they've made that day. So they did it for 12 days. So the temperature, when the temperature was 11.9 degrees Celsius, they made a sale of $185, 14 degrees, 215. So to all the way to 25 degrees, we have 614. So here's the same data as a scatter plot. So this is like, so for example, that day, that's like day one for a temperature of this, you have ice cream, amount of sales of ice cream is this. Okay, so when we plot it, we can see it this way. So on this axis we have the temperature, on that axis we have the amount of sales. So for a temperature of 11.9, we have sold for 185. So 11.9, so 12, so 12 is somewhere here, and 185 is somewhere here. So they meet at this point. So this couple is being represented by this point. I mean, this one here, this couple on here, is represented by the point below over here. So the same goes for every data values. Okay, for every data values in here, for, like, this is represented as a point, and this one also. So you obtain the following graph. As you can see, if we were to draw a line like this, we can see that there is a linear relationship. There is a relationship between the temperature and the sales, and that relationship is a linear one, positively related. If one is increasing, the other is increasing, and as one is decreasing, the other are decreasing. And here is the interpretation: warmer temperature, so that means when the temperature gets increased, leads to more sales. So the warmer the temperature, the more sales you make. There is a relationship between the sales and the temperature. Okay, so we want you to do the same thing for the we like to do the same thing for the losses and the insurance payment. So to do so, what we're going to use is we're going to use one of the Excel function called the scatter plot there. So we're gonna select our variables. So I said, like, to select the entire column, like I can go like this, Control Shift down, and then I'll select. But what I want is this one, A1, and I press Control A2. Okay, now let me do it this way. Okay, so now I go to Insert. Once I'm Insert, okay, I go now to Scatter, and I can see the different type of scatter that I have here. The one that I need is scatter with only markers, compare pairs of values. Okay, so here we want to compare pairs of values. It is you when the values are not in x-axis order, or when they present separate measurement. Okay, so let me select this one. That's the one that I would like to use. And remember, the losses will be on my x-axis, and then my payment will be on the y-axis. Okay, that will produce my scatter plot. So let me move it on the side. Okay. Okay. So here's my scatter plot. I'm going to remove these lines. So to remove this, I press the backspace on my keyboard. So backspace. Okay, I'll remove those grid lines, and I'm going to use another format because there are different format of this. I'm gonna use this format. I think layout number 1, where I can see like the x-axis. I have axis titles, and here titles and the legend. Okay, as you can see here, and there are other format, but I'm gonna stick with this one over here that I've done. This one. Now this is another format, but this is what I want. So I'm gonna remove. I press backspace. I select the line first, and I press backspace on my keyboard. Now I'm gonna retitle this. So here, like I was saying, the losses are on the x-axis, on the horizontal axis. So here I'm gonna call it losses, and here I'm gonna call it insurance payment, and the title will be losses versus insurance payment. Okay, so here is our graph, and from that graph we can see the difference between the relationship between the losses and the payment. As the losses are increasing, the payment are increasing also. So, and after certain value for the losses, the payment is plateaued, as we can see over here. Okay, so the fact that we put a maximum benefit allowed to limit the costs of for the insurance company. Okay, all right. So that was for the scatter plot. Now the next question is about so here is our scatter plot when we have it on our report. So some of you, I know that some people have a hard time copying the. So all you have to do is to come here, press copy, you select, press copy, and then you go and paste it on the Word document, and then you come in the Word document just like this one, and then you paste it, Control V, paste, and then that will paste the diagram. Some people have a hard time actually doing this. Okay, you can increase the size or decrease or whatever. Okay, so going back to the project 8, create a correlation matrix establishing a relationship between the losses, the insurance payment, as well as the insured payment. So we want a correlation matrix that shows the relationship between these three variables. So let's go to the definition of a correlation matrix in the first place. So a correlation matrix is a rectangular array of correlation coefficients relating to two or more variables. So let's x1, x2, x3 all the way to xn be random variables. And now let rho sub x sub I, x sub j be the correlation coefficient between the variable x sub I and x sub j, where I is between 1 and n and j is between 1 and n. So the correlation matrix is given by the following table. So when we're talking about the correlation matrix, you put here your first variable and your first variable versus your second variable, your first variable versus your nth variable, and here you could record the different correlation coefficients. So here it gives you the correlation coefficient between this variable and that variable. Now this correlation coefficient here gives you the correlation between this variable, between x2 and x1, etc. So this one here shows you the relationship between xn and x1. So similarly, we have the same for all of these values. Okay, so normally here is x sub 2, x sub 2, oh yes, and all the way to here x sub n. Okay, so this is like basically the definition of a correlation coefficient. Now what we want to do is to create a correlation coefficient. I can do this in two ways. I can have like here, like it's small, I can create like a small table, press right here losses. Here I have losses. Here I have insurance payment. Insurance payment again. No, insured payment. Okay, now I'm going to copy these, create a table. Okay, going to cover the border. So copy, then paste transpose, paste special, paste transpose. Okay, it's not working, so let me try it in here. No, never mind, let me simply write the same thing, insurance payment. And then insured payment. So here I want to do correlation between losses and losses, equal to correlation. So there is a correlation function between the losses, the variable losses, and the variable losses. Losses, and then the other variable is also losses. Obviously, it has to be equal to 1, okay, because it's the same values and everything. Okay, as you can see, 1. So now the correlation between the insurance payment and the losses. So we go to the data, correlation between the insurance payment and the losses. Insurance payment is here, and then losses are here. And you obtain this value, okay? And we do the same thing for the other, so equal to the correlation coefficient between the insured payment and the losses. So the insured payment is this one, so shift down, and the losses are these values here. Okay, now another way of doing it is to, so I do the same thing for the others to fill them out. Another way of doing it will be to use one of the functions of Excel. I'll go to data, and then in data here you'll see that you have like in data analysis, you have solver, you have data analysis. Some people do not have this part in by default in the Excel, so they have to, this is like an Excel add-in. So to have this add-in, you go to options, so you click here, go to Excel options. Depending on the version of Excel that you have, go to Excel options, and in Excel options you go to add-in, because you want to add a new function that doesn't exist, add-in. And in add-ins you select manage Excel add-in, you press here analysis tool pack, okay, and then go, and normally that should add data analysis here, okay. So let me do Excel add-in, okay, analysis tool pack. If you don't have it, okay, you go here, you press, I've already selected that. No, like by default it's like that. So I add the analysis toolpack and I add the solver add-in and then I press OK. Okay, that's another way of doing it. And then this is going, and then when you select this, you come again here one more time and then add-in, you select this and then you press OK, and then this is going to appear. Now once you have this, you press data analysis. What you want to do is the correlation. You press OK. Input range, meaning that what do you want as input? My input, I want these three are my inputs. I want to find a correlation between those three variables. Okay, so my input range will be like everything in here. Now here Excel is asking me if I want to include the labels like the here Excel asks you if the first row, meaning this row here, represent the labels or the names of the data values, and that is true. Yes, this is the name of the data value, so I need to select here. So input range, let me select all of these, control shift down. Okay, and then when I do that, here shows me like this small bar here that Excel presents to me is like a bar where I can actually select the values. And when I finish to select the values, I press here. Now I said to Excel that the first rows represent the labels. These are labels, right? So I press this. Now output options. So here Excel is asking me where I want to put my correlation matrix. Do I want to have it in a new worksheet, so like it will be like on another page, or do you want to have it in a new workbook, meaning that a new even Excel spreadsheet, or do you want to have it on this paper? So output range, and I select where I want to put my values, my correlation coefficient table. I can put it somewhere. Let me put it near the other one that I've created. Let me put it in here. Yeah. Okay, yes, let me put it here. No. Okay, I press here, and as you can see, and I'm done. And I press OK. So automatically I'll obtain my correlation coefficient. Okay, so I don't have to do like all the calculations and all that. So here, as you can see, these cells are empty. This one is empty, this one is empty, because the value here is being repeated here, value here being repeated here. So that's why they are not even showing up. Okay, so this one repeated here, this one repeated here, this one repeated here. So so Excel did not found judge necessary, because it's the same thing. Losses, insurance payment here, losses and insurance payment, the same value goes here. So but what we can do, we can actually decide to to add those values. So I can copy this, copy, and then let me do paste transpose, paste transpose, oops, paste special, and then paste transpose. Now copy this line here, copy, cut, paste, cut, and then I paste. Okay, now I can delete these because I don't need those. Delete. Alright, now let me actually format this a little bit. I go to home, and here I can put borders in all the cells, and this is what I have. I can enhance this further by putting the conditional formatting, and within conditional formatting I put color scales. So those colors will allow me to actually have a better view. Okay, and here I can put them in bold character here because they're titles. Okay, and I can center these values. Okay, and then I can reduce the number of decimals. Let me see. Okay, to 3 decimals or 4 decimals. Alright, so here is my correlation coefficient table. Okay, so that shows that, for example, losses and losses, there is a strong relationship between the losses, of course, because it's the same thing. Insurance payment and losses, as we can see that we have 0.95. That shows that there is a strong positive relationship between those two, the loss in the insurance payment, losses and insured payment. We can see that there is a strong relationship between the insured payment and the losses. Okay, 0.96. Knowing that the correlation coefficient is between -1 and 1, this is very close to 1. That means there is a strong relationship. Now, relationship between insurance payment and let's say insured payment, we can see it. Insurance payment and insured payment, 0.84, 78, etc. Okay, so back to the report. In the report, we have the scatter plot being drawn, and here we can see that we have our correlation matrix establishing the relationship between the losses, the insurance payment, and the insured payment. This is what we have. So, but based on the result obtained from the correlation, what can you say about the relationship between the losses and the insurance payment? So here's that. So you have to do, you have to say like the relation, talk about their relationship, and based on the result obtained from the correlation matrix, what can you say about the relationship between the insured and the insurance payment? Insured and insurance payment. Okay, you can see that there is a relationship, and what can you say about those? Okay, you can see that there is a strong relationship, positively, these are positively correlated. There is a strong relationship between the two variables. Yeah. Okay, so that's pretty much it for the the project assignment. So in your project assignment, you have to do something very similar.